have very great collaborations with industry. They always bring new subjects that push the limit of the beamline. That is, we always have to develop new things for industry.
What I like most is to find solutions to their problems.
They really want a result compared to a researcher who are more on, we would like a result.
But it's true that it's also exciting to see the direct application of your research to specific subjects which are going to be part of the daily life.
And you feel more useful for people because you see that, okay, they've got a problem, so you are there to solve the problem.
Large-scale instruments like the ESRF and the ILL are well known as places for cutting-edge fundamental science. This is forgetting that about 1/3 of their users are industrial or linked to industry.
At the ISRF we do a vast range of work. We're largely academic, but there's a huge amount of work that we do through the academic program with industry, and we also have industry that come and do direct proprietary work at the ISRF. They pay and they get access, and we have a rapid access for them, and they keep all the results confidential.
Industry's needs are important to the ESRF and ILL. Companies find unique materials characterization tools for their research and innovation.
Synchrotron X-rays are good for industry because they are extremely intense. They're like a laser beam of synchrotron X-rays. They're 1 billion times the kind of intensity you get from a laboratory source. They're tunable, which means that we can pick out certain elements within a sample and make them kind of light up like a lighthouse and detect where they are. We can focus the synchrotron X-rays down today to maybe 10, 20, 30 nanometers according to the beamline. With the upgrade phase 2, we'll be able to go even smaller than that. We can go to very high energies, which means we can penetrate into large, bulky objects and look inside. And we can do that at the very fine, high spatial resolution that I mentioned earlier on. And because they are intense, we can also do things very, very quickly. So we can monitor dynamic phenomena in real time because we can make the measurements very, very fast.
A few meters from the ESRF, industrial users can also benefit from the world-leading neutron source, ILL, to characterize their materials in a non-destructive way and with a high resolution, even for few centimeters thick samples or large objects.
So this is a good complementary between X-ray at ESRF and neutrons at the ILL. X-ray is very efficient for very high resolution characterization in the range of microns or even below. With neutrons you can see details in the nano or micro scale, but you can have an image or a study on large pieces which are 10 centimeters, 20 centimeters or even more. We also did some testing for wings for aerospace applications, for example.
In order to help industrial users with their experiments, both institutes have permanent scientists and engineers who offer support.
We don't have to be experts to come here because there are different levels of accessing the beamlines. So either you are an expert and you come and use the beamline as you want, or you ask us to actually help solving your problem. And some people are very talented in some areas, even some specific experiments can be done.
A support provided at all stages, from conception to experiment.
It can go from sample preparation, data measurements, or delicate data measurements also, data analysis.
Industrial users can even use ESRF partner services to get experiments done, such as Photon, based in Grenoble.
We try to be a bridge, but more than a bridge, because we offer not only the access to the facility, but also all the development that would be necessary to answer a question. Basically, we have two big sectors where we are active. One is the cosmetics sector, and one is the more composite material sectors.
And as one of the main obstacles for industry is to know who to contact, ESRF and ILL have dedicated services.
Within the ISRF, we've set up the Business Development Office, and we're the unique link for industry to come into the ISRF, to talk to us, to use us. We provide quotes, NDAs, MTAs according to industrial needs, and we're sort of their point of contact to make it easy for them to get to use the ISRF.
To better account for industrial constraints, and especially time, New tools are developed regularly, like the fast and completely automated sample changes for crystallography on so-called massive.
The first advantage is the robot will be, and the beamline will be used 6 days a week, 24 hours a day. We want to provide to users a service which is completely free of any journey, which means that they send crystal and we process them automatically without their presence.
Cutting-edge science that can apply to everyday life objects.
The idea was to study the 3D distribution of compounds inside a Bouillon cube, and this is to know the mechanical properties of this Bouillon cube. So, for example, it was possible to distinguish the sugar, the salt, the porosities, the starch, and the fat.
Every day, about 70 different experiments are run at the same time in the two facilities, covering all imaginable fields of R&D, accessible to larger companies as well as to SMEs.
A wide range of sectors are concerned, so transport, biology, medical applications. We are, for example, developing a new kind of radioisotope, which would be very efficient for the treatment of some cancers.
Everything can be done at the ISRF that you can imagine. If you can think of any material, we can look inside it, we can look around it, we can watch it as it changes dynamically, and we can watch this at high temporal and spatial resolution. So we apply to just a huge range of material, be it concrete, steel, drug discovery, nanotechnology, electronics, catalysis, chemistry, you name it, we can do it.